Hello and welcome to Preliminus. Let's look at limits in this video. Now, a limit is the concept of taking a singular point in a function and looking at how it behaves in and immediately around that single point. As you squeeze that area that you're looking at, it can tell you a lot about how that function behaves. Now, if you pull back the curtain on calculus, a lot of the gears that interlock to make calculus work use the concepts of limits as a method to understand the derivative and the integral. So let's jump straight into it.
Let's start out with a fairly basic function. We're going to take x squared and look at it right here at x equals 2, which means that our output is going to be 4. This point here, you can imagine approaching from either the left side or the right side towards this point along the function. And you can imagine that going both ways, there's a region here that you would be pushing inwards this interval in order to get to this point. And you could sort of zoom in right here, and you would have the same thing no matter how much you zoomed in. You could pick this interval, be whatever you wanted it to be, make it arbitrarily close to this point, and no matter how close you got, that you would be approaching where this point exists. And the way that you would write this is the limit as x approaches 2 of x squared is equal to 4. So you'd have your function in here, and you'd have here x going to, or your variable going to, whatever point you're looking at. Here x equals 2, and then your output would be whatever that point would be equal to. Now this is not the only situation. This is the simplest way that you would go about this, that this point actually exists where you would expect it to be. Let's imagine a runner going along a little jog. Okay? Imagine that he comes across mile markers every so often. And you can imagine the runner going along a path that is the function. And that these mile markers are just the points that you're considering. And so these mile markers I'll denote from here on with these points along this line, which would be the function. So imagine that you're watching this runner go along his path, and at some arbitrary mile marker, let's say as you're walking you blink, and you don't see where he is at this exact point. You see where he is all the way up to here, and you see where he is here and afterwards, but right at this point you blink and you miss it. But you can fairly confidently imply, based on your knowledge, that this is where he should have been. Now, of course, you can't be 100% certain, but as these points get closer and closer and closer, same thing as this interval up here, your confidence of where he actually was goes up. So let's consider another stranger scenario, much less realistic. Let's say that he comes across this strange feature, where he has an infinite well followed by an infinite mountain. I know you don't come across many of those when you're jogging, but let's say for the sake of a function that goes to negative infinity and infinity. Let's say that you have your mile markers here and here as you're going along. So your jogger here is going to be going down into this pit, and you'll be able to see him going deeper and deeper and deeper and deeper until finally you get to this point where you blink and you can't see him anymore. And then when you open your eyes again, you'll see him going up on the other side, coming from the bottom of the depth at negative infinity and going all the way back up here. And you can imagine that when you blink, that he goes from moving downwards to moving back upwards. So you can imply that he would be at negative infinity when you blinked. because that's the only place that would make sense for him to have been going downwards before you blinked and then upwards after you blinked. Same thing over here, that he'd be going up and up and up, and then you would blink right here, you wouldn't be able to see what was happening, and he would come down, 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 down. You don't know what happens at infinity. Since infinity would be infinitely far away, we can't describe its motion up there very well. But you can know that he should be at infinity at this point, because that would be the only thing that would make sense for when you blinked, because you'd see him going up and up and up and getting larger and larger and larger real values, and then down, 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 smaller and smaller values back until you get to this baseline. Now finally, let's consider here, he comes across maybe a pothole where there's a discontinuity in the path. At this point, if you were to have a mile marker here, let's say you blink and you see him over here, and then you see him over here afterwards. Now you know that he should have been right here, but let's say in reality you're told that he jumps. And so he sort of does one of these motions where he goes up and then he comes back down over here. This would be called a discontinuity in the function and would be representative of there being a hole at one of these points, which is usually drawn like this. And it could be that there's just a hole and there's no other point at x equals 2 in this case, or whatever point you're looking at. It's also possible that in the function, you're given a point that it actually exists. You can still look at the limit approaching this hole, even if you don't know what happens here, even if this doesn't exist and you're given another point up here. You're still able to analyze that point. Now some very interesting things happen when your function as an x approaches 0. This is frequently used in the calculus concepts of a derivative of an integral. At these very small regimes where you have x approaching 0, you would want to analyze this limit, and here your function would actually be the definition of a derivative and an integral, which we will cover in their own videos on the concepts of how the derivative comes about and how the integral comes about, and how you can use these types of limits and their behaviors to understand the infinitesimally small aspects of how you would go from finite algebra down to calculus. And we'll also have Uthej release a video on some practice problems in order for you to get a more visceral understanding of where these points would actually exist and how you would interpret their values.
For any questions you may have or topics you'd like us to cover, let us know in the comments. Thanks for watching. Hope to see you next time.